one question might be like this: show that some grammar that they give is ambiguous. Okay. If they give you something like this, it's very good, easy to prove. Otherwise, you have to think of a string to prove the ambiguity. And you can see you have to also draw the parse tree. Okay. Now, let us see one question. Let us take this question. Is it ambiguous or not? I have to prove, right, for this. So this expression is ID plus ID star ID. And we can say it is ambiguous if and only if it has multiple parse trees, or if it has more than one derivations. Okay, if it has more than one leftmost derivation or rightmost derivation, which ultimately means that it has more than one parse tree. Okay, so let us try to draw the parse tree for this. So first I need plus on the left. So I can start with, I'll call this as 1, 2, 3 and 4. I'll not need 3 because there is no bracket over here, right? So let me start with 1. Okay. So E derives E plus E. Okay. Now this first E I have to convert it into ID. So you can see E derives ID, right? So I can say ID plus E. This is using the fourth thing. Now after this, I want ID star ID. So this will be ID plus this E will be expanded as E star E. This is using 2, correct? Now after this one has to be converted into ID. So ID plus ID star ID, right? This is using 4, sorry, E, and again ID plus ID star ID using 4. Okay. So this is one leftmost derivation. Why did I call it as leftmost derivation? Is because the expansion from non-terminal to terminal is happening from left to right, correct? So how do we write the tree for that? E derived E plus E in our first step. Then this one became ID. Then this one was expanded as E star E. And then this became ID. And this one also became an ID. Okay. Let us see if I can have one more expansion, same leftmost derivation. So I can start from any starting productions where here starting symbol is E. So instead of starting with E plus E, I will start with E star E. Okay, this was production 2. Okay. Now here I want plus. So this E I will expand as E plus E and star E. Correct? This is using 1. And after that, the first E I will convert it into ID. So ID plus E star E using 4. Next, second one. So plus ID star E again using 4. And finally, ID plus ID star ID. So as you can observe, both are leftmost derivations only, right? So how will the tree look like? E derives E star E, correct? And then this E was expanded as E plus E. And then this one was ID, ID and ID. Okay. So the question asked us, is it ambiguous? We have to tell yes, it is ambiguous because it has So the grammar is ambiguous. Why? Because it has two, or we can also say multiple leftmost derivation for string id plus id star id. Next, it was asked to draw the parse tree. We have drawn the parse tree for the string. Again, you have two parse trees. So because of that also, it is, ambiguous. Okay. Now let us see one more question. Something like this also might be asked. Like there is a diagram which is given, and this is a language which is accepted by some state machine. They'll give you some regular expression, and you have to tell whether it belongs to this or not. Okay. For example, the first one is given as BA union AB star A. Correct? Whether it will accept it. Does it accept BA? That means union means what? It should accept either this or this. Correct? So you see whether it accepts BA. So for BA to be accepted, what is the path you will traverse? Q0 on B will go to Q3, and from Q3 on A you are going to Q1, correct? And as you can see, Q1 is final state, right? So this is okay. For BA it is okay. Now let us see AB star A, whether it will accept. You can see here from Q0, if I take AB star A, from Q0 on A will go to Q1, correct? And then B star means 0 or more B's, correct? So it can be any number of B's. So on B's it will go to Q2, right? And on A from that, it will come back to Q1, right? So if you watch here, you will feel that, okay, I have come back to Q1. So it should be accepted. Both it is satisfying, right? Left hand side or right hand side. But if you observe more here, AB star A means B may or may not be there. So you also have to see whether it will accept just A and A. Okay, whether it will accept just A and A. And AB star A can generate, as I said, AA, or it can also generate ABA, right? Single B and A. Will it accept that? Okay. Now coming to single ABA, it does, right? A, B and A, and you have come back to the final state. But will it accept AA also? Because B star, when we say 0 or more B's. And you can see AA. First A will come here, and on a second A I don't have transition from Q1 at all, isn't it? For AA, from Q0 on first A I came to Q1, that's all right. What about second A? There is no transition from Q1 on A. If there is no transition, we usually assume that it goes to a dead state. Okay, so that means it will not be accepted. So the first one does not describe the language. Okay, so the question was whether it correctly describes the language. The first one does not describe the language because it cannot accept AA. I hope this is clear. You have to draw the pictures like that and explain. Okay, what about the next one? A, right, followed by BB star star, or here you have initially two, no, union, BA followed by BB star A star, correct? So what is the minimum string here? Just A. Because the star is there here, this need not be accepted at all. Just A, is it accepted? Yes, just A is accepted. Okay. Now what about A followed by BA? Because this is a star, right? It need not be there. So ABA, is it accepted? You can see A, it's going from Q0 to Q1, and on B it's going to Q2, and on A it's coming back to this. So it will take you to Q1. So that's okay. That's also accepted. Okay. And what about A, B followed by any number of B's, right? BB star means what? Actually B plus. 1B compulsory. After that, any number of B's. So will it accept 2 B's? Of course it will, because here for any number of B's you are remaining in Q2, and on getting this A only you are coming back. So you can see on A Q0 to Q1, on B to Q2, second B Q2, and then on an A you come back. So the first part is okay, right? First part means A followed by all this is okay. Now let us see whether it is accepting this. And this is repetition, so it's okay. This star we already handled here, and 1 we handled here, and multiple means the same path will be followed, so no issue. Now minimum string for this is BA, correct? So is BA accepted? Yes, on B Q0 to Q3 and Q3 to Q1. So BA is accepted. Okay. Next minimum string is BA. Why? Because this is star, this BA followed by this BA. So will it be accepted? So from Q0 on B I come to Q3, on A I go to Q1, on B I go to Q2, and again on A I come to Q1, and Q1 is final. So this is also accepted. What more? Multiple occurrences of this, right? So if you see this, BA, B followed by any number of B's, and then A, correct? So will it be accepted? So you can see B comes to Q3, right? On first B. So then from Q3 on A, you go to Q1, correct? And Q1 on B is going to Q2, and Q2 on B will remain in Q2. And then Q2 on A will get you back to Q1, which is a final state. Okay. I hope this is clear. Otherwise also I'll again do it once more, because you might have forgotten we did it long back. The question is whether they belong to this. Let me just take second one. First understand the meaning. It says A union BA, which means the starting can be A or it can be BA. Or, right? Union means or. A or B. After that, this is a star. So you may or may not have. Okay. Anyway, let me write it. After that, it has to follow this pattern. So I can have this or I can have this. It has to allow me to use this pattern. What is the meaning of star? Star means this is optional. May or may not be there. So when it's not there also it should work. When it is there also it should work. Okay. So let me take the first one. Since this is optional, what are the possibilities? Let us take this. What are the possibilities? It should accept only A. Okay. It should accept A followed by BA. This B star is optional, right? So followed by BA. And if this also is used, so multiple B's and A. Okay. And then this can repeat any number of times, right? This star. So does it accept only A? You can see Q0 on A goes to Q1 and it is final state. Yes. Does it accept ABA? So ABA you can see Q0 on A is going to Q1, on B is going to Q2, on A it's coming back to Q1. So yeah, it's accepting this. Okay. Does it do this? Q0 on A comes to Q1, on B goes to Q2, and you put any number of B's, it remains in Q2, and on A it will come to Q1. Yes, of course. So similarly, you have to do for this also. Okay. Its minimum is BA, after that BA, BA, or you can have BA, any number of B's followed by a B. And show that for all these three cases also you are going to reach the final stage. And if it is satisfied, then we say, yeah, this is correctly defining the language, which did not happen in the first case, if you remember, because the first example was it should accept just BA, right? Or AB star A, right? For BA, it was okay because starting from Q0 on B, you went to Q3, on A, you came to Q1, and this is final state. So this was okay. Now, when we came to AB star A, what is the minimal string here? AA, because B star star is optional. Or you can have ABA, or you can have any number of B's followed by A. Now, coming to AA, Q0 on A came to Q1, but there is no transition from Q1 to A. So it's dead state. Okay. So even if one thing is not accepted, this is not, it does not. Okay. Correctly define whatever is this diagram. Okay. So that's the way you have to answer to those questions. Now let us see, you might get a question like this. Let L be is equal to W, means it has strings derived from alphabets AB. Every A in W is immediately followed by at least one B, right? Every A is immediately followed by one B, right? So this means, this you should think like this, okay? If A is there, it should be followed by B. If only B's are there, no issue. Correct? Right? So, what all will be accepted by this language? For that, you can see, you write the regular expression. So, what is the regular expression for this? Okay. So, as I said, I can have only B, or if at all A is there, it should be followed by a B. And this can repeat any number of times. Correct? See, I can have nothing also, because you saw W belongs to AB star. Star is nothing, right? So if I don't use anything, then it's an epsilon, a string. Will this B star represent a single B, double B, any number of B's? There is no restriction on B's, so that's okay. But here you can see, if at all A is there, it should be followed by at least one B. So minimum is AB. What about ABB? Because at least, so I can have more than one B. Of course, you can see, for AB, I'll use this part, and for another, I'll use this part. So that's okay. So if I have A, B, B and many B's, that's okay. For AB and AB, I'll use this B part because it's a union, no? Right? So I'll use this part, or let us make it as 1 and 2, second part. And for any number of B's to be generated, I want to use the first part. So this is my regular expression. Second one says, generate a regular grammar. Correct? Generate a regular grammar. So we'll start from a starting symbol. As you can see, epsilon, nothing is there means epsilon, correct? Or it should generate any number of B's. So B, S or epsilon. Okay. S derives BS. This is to generate any number of B's. Like for example, single B you want? Okay, S derives BS, and next time I'm going to put the epsilon. So S derived B. Okay. I want multiple B's. So S derives BS. Again I'll expand this B, right? So BBS, I can go on generating any number of B's from that. And ultimately I'll put epsilon and stop. Right? So for all this part, this is enough. But S also generates A. If A is there, it should be followed by at least one B. So, right? at least one B. So I can say AS. If at all S has derived AT, I'll tell you why. If I make it as AS, what happens is single A also will be accepted, right? If I do S derives AS, this S can be replaced by an epsilon, so I'll be deriving A, which is not allowed. So if I have A, I should have B. So S derives AT and T derives BS. I hope this is clear. Why? Because now you see, if I want to create this AB, something like this, I have to start from a starting symbol. So I'll start with this and I'll make it as AT. Okay. Because if A is there, B is compulsory. So this T will take care of this. So T can be expanded as BS. Correct? So I have created these two. Next I want A again. So only way A again I can do is by using this. So S derives ABAT. Correct? So after this I want this B. So obviously T will take care of this. So S derives ABABS. Right? And after that, for generating these two B's, I can use the first one. Correct? So S derives BS. Right? Again, this S can be expanded as BS. And ultimately, this S will be epsilon, generating whatever I want. So this is the regular grammar. Okay. And then the third part of the question was construct an FSM to accept. Construction of FSM is very easy, right? Starting symbol. On B, you remain in S, correct? So on B, you remain in S. S also derives epsilon. That means without consuming anything also it should be accepted. So S will be made as the final state, correct? S on A will go to T. On A, it will go to T. And T on B will come to S. Okay. Now let us see if it rejects what should be rejected. For example, AA should be rejected, isn't it? Because if there is a A, it should be followed by B. You can see for first A, I will come to T, but there is no transition that I have written for the second A, which usually means it will go to dead state. Okay. So it will not be accepted because we will not reach final state. What about just B? You can see epsilon is accepted. 1B, any number of B is accepted. What about AB? A, should it be accepted? No, because after AB is not there. So A, B and A, you are coming back to T. What about AB, AB? It should be accepted. So on A, you are coming to T, B, back and back. It's final state. Okay. So you can see one more question can come like this. Okay. You have any doubts to ask me? Did you understand whatever was done now? Do you have any doubts to ask me regarding test? Are you people in the class? No doubts. Okay. So then I'll stop for now.